JEE MAIN 2026, 2nd April Shift-2, Physics Section A, Question 30. Let us visualize the logic circuit. We have two inputs, X and Y. Each input first passes through a NOT gate, producing X prime and Y prime respectively. These inverted signals then feed into a NAND gate, and the output of the NAND gate is the final output of the circuit. The question states, if X and Y are the inputs, the given circuit works as blank. The circuit has inputs X and Y, each passing through a NOT gate. The inverted outputs then enter a NAND gate, and the NAND output is the final output. The options are A, OR gate; B, AND gate; C, NAND gate; D, NOR gate. The key concept here is De Morgan's theorem. The first law states that NOT of A and B equals NOT A or NOT B. The second law states that NOT of A or B equals NOT A and NOT B. Remember, a NAND gate performs NOT of AND. Also, applying NOT twice gives back the original value. So NAND of X bar and Y bar equals NOT of X bar and Y bar. This is where De Morgan's theorem will simplify our expression. Step 1. The NOT gates invert each input. Input X passes through a NOT gate to become X bar, which is the complement of X. Similarly, input Y becomes Y bar after passing through its NOT gate. Step 2. Now we apply the NAND gate. The NAND gate receives X bar and Y bar as inputs. So the output is NOT of X bar and Y bar. Now, by De Morgan's first theorem, NOT of X bar and Y bar equals X plus Y. Here plus means OR. Therefore, the output of the entire circuit is simply X or Y. This circuit behaves as an OR gate. Step 3. Let us verify using a truth table. For X equals 0 and Y equals 0, X bar is 1, Y bar is 1, X bar and Y bar is 1, NAND gives 0. X or Y is also 0. For X equals 0, Y equals 1, X bar is 1, Y bar is 0, there and is 0, NAND gives 1. X or Y is also 1. Similarly for the remaining rows. Notice the NAND output column matches the X or Y column perfectly. This confirms that the circuit is an OR gate. The circuit is equivalent to an OR gate. Starting from X and Y, the NOT gates produce X bar and Y bar. The NAND of these inverted inputs gives NOT of X bar and Y bar, which by De Morgan's theorem is X plus Y, that is, X or Y. The correct answer is option A, OR gate. Here are some exam tips. Remember these gate combinations. NOT gates followed by a NAND gate gives an OR gate. NOT gates followed by a NOR gate gives an AND gate. Both NAND and NOR are universal gates, meaning any logic circuit can be built using only NAND gates or only NOR gates. The quick shortcut is if inputs are inverted before a NAND, you get OR. If inverted before NOR, you get AND. These follow directly from De Morgan's theorem. Like and subscribe for more JEE MAIN solutions at MAGPIEHUB.